It is not okay.
You talk, and then I give you the as a presenter now only.
You can get the privilege because Cisco is
Just
making
I check
something.
this.
Okay, it's okay. Got the privilege, that's okay. It's nothing here. Thank you for considering that. So we'll see today's lecture on software engineering and project management. Right now we are having total 59 participants here. Okay. So here I am giving you the today's lecture on class-based modeling in the what we call as this class-based modeling is used for creating or for defining the different classes in the software. Classes are actually used to design and develop the software in terms of what we call as a structure. Okay, so when we say class-based model and when we say this is a structure, okay, we are actually dealing with something what we call as an architecture of the entire software project or whatever software that you are taking. So today's outline of the presentation is first we are going to see what is our objective and then we are going to see what is the class-based modeling in detail. Okay. So, what are the objective of today? We are today simply simple objective is that we are going to learn about the class-based modeling. So, what exactly are the classes? So, let me draw here one thing. See, here if I draw a simple box, okay, and I make partitioning this box into three parts. Okay. Now, if this part, first part, let's consider this A stands for animal. Okay. A stands for animal. So this is a super class animal because you are having different type of animals. Some are mammals, some are not the mammals. Okay. So here you are having say, let's say suppose I am simply showing now the head part of this class. These two parts are not shown. Let's consider these are the mammals. Let's consider this class as a name as N. Okay. So here you are having the non-mammal. Now what is object? Right now here you are having this cat. Okay. So I can say the cat is an object. Okay. Cat is an object of type animal A. Okay. So we are having the class object animal. But when you say animal, it is a super class. So what we can say here, if you want to go with the definition, class is a mammal, cat is a mammal, and mammal is an animal. So this is what we call as a relationship. So if you go with the thing, this is what say. So their animal here is considered as an abstract class or the super class, while the mammal is considered as what you can say the child class. What this mammal does is that it inherits the properties of animal. Okay, all the properties of animals are inherited, but there are few properties which are only with mammals. They are not available with all the animals. For example, non-mammal animals don't have the properties of mammal animals. Okay, and then these animals, mammal animals, they may have the two types or three types. First, what you can say, consider here you are having the animals with shell, animals with no shell, and likewise. So, what are the different animals with shell? Let's say we can call this class as MS. Okay, we call this class as MS. So you know that is the tortoise or turtle is a mammal with a shell, or you can have here the mammal with the four legs. Okay, so what we can say, you are having mammal. Okay, general mammals we are having elephant, cat, dog, and likewise. And then you are having the erectus. Erectus means bee. Are the mammals who can stand on their two legs and can have the intelligence. So we are having here the human beings. Okay, Homo erectus, what we call. In a non-mammal, we can go with the snakes and likewise. Those are again a type of animals and something. In the same way, you can have a class. Okay, you can have a class where you can have the bird. Let's call this as a bee. Bird is a super class. So when we say class, term the class-based modeling, we are actually trying to find out the entire database or data used in a software, and we are trying to divide that data in such a way that we can go with what you can say the different thing. So different things means what you can say these databases. Let's say suppose if you are in a software where you want to classify the different where you want to classify the different say animals itself. You just someone asks you to design and develop a software simple app, okay, which will differentiate between the different animals. So you will create animal type, the super class. What are the basic definition of animal? So every living being which satisfies that definition is considered as an animal. Then comes the sub definition. You require to reclassify these animals and likewise, and so we go with the learning this. So what is class-based modeling? If you see in class-based modeling, it represents the objects. Now what exactly mean by the object? So object is a one entity, what you can see. For example, if I say an array as a class, okay, an array is a class. What we are having in an array, that a of I is can be considered as an object. Okay, so if I am having an array of integer numbers, there is no possibility that you are having the element which is called as which can be called as the say something like you are real number. So 3.0, 3.6, 3.7, this won't comes into the array of integer. So array of integer is can be considered as a class, and every a of I, that means a of 0 is the one object, a of 1 is the another object, and may have the integer value. So that is what is the object. So when we say class-based modeling represents the objects that system will manipulate. So there is a similar type of data which is or a similar type of data. So the data is gathered together. Or you may have a similar type of entities. For example, if I say entity here, you can consider a human. Okay. So me, you, we all are the human. Okay. So human is a super class, and then we are the entity. So whatever the basic properties of humans are there, they are available with you as well as with me. But there are some special properties. You may consider a dancer. Human can be a dancer. Human can be a fighter. Human can be a painter. Human can be a musician. And likewise, but not all human can be musician. Not all human can be. So you have got the entire range of subclasses. Yeah. And in that subclasses you are having that particular specific skill sets, or what you can say the attributes, or what we call as a methods or operations which are only available with that particular subclass. So when we say class-based modeling, we are trying to identify first all the similar objects, and based on that common similarity we create what you can say a class. Then we are having the all common operations with this. For example, if I say a bird means bird can fly. Yeah, but mosquito also can fly, but mosquito is not the bird. So there must have to be something which actually differs this mosquito from the bird, and that you have to find out in terms that is mosquito is not a bird because it's not having claw, it's not having say some features of the birds like feathers and something, and then you can come to know that. But they have the operations. So even if they are in the operation, there are certain operations which are only, but there are not all birds can fly. For example, if you go with a penguin can't fly. Okay, so these operations which you can do or a class can do is called as the methods or services. Okay, and then you are having some relationship between these classes. For example, if I am having a class here a cat, Okay, animal is these two objects are there. C is the that is cat is the mammal of type animal, and then here you are having the rat. Okay, so when we say rat is also a mammal of type animal, but there is a relation between this cat and rat. Okay, while cat is a hunter, the rat is actually the hunt, or what you can say is the food for this cat. So when we say cat is a predator which eats the rat, or we can say a rat is something, and how what is the relationship? One cat can eat many rats, so we can have here the number one, and here you can have them for many as a star. So one to many relationship is there, and that is called as a relationship. That is called as a relationship. It may be hierarchical, it may be aggregation, it may be something. So when we say class-based modeling, we are actually trying to find out this relationship. Now we said that is a cat is there, rat is the food of this cat, but something like, say, suppose if you go with the body is a one class. When you say body, you can consider our body. Okay. So body is one class. Let's call this body as a one class, and this is shown with a B. Now here you can have the aggregation. What is the body? Body is actually the combination of different you can say subclasses. And what are those subclasses? Each body is having some head, then you are having torso, then you are having hands, legs, and likewise. So when we say this, we are actually talking about something aggregation. Means if I say a wall, okay, or you can say if I say the front wall of a room, it actually the aggregation of door, window, and wall. Okay, so that is what called as aggregation relationship. So there are these relationships are there in a class that we require to see. So in a class-based modeling, we have to first find out a common container. Basic example is an array. Array is a common container of similar type of objects. Similar type of objects means the values here. But if you expand this to the entity, okay, we can say and this as a something. Then every such entity has some attributes. Okay, and every entity is capable of doing some operation. For example, if we say a cat as a animal as bird as a class. Okay, what are the attributes for a bird? A bird will have certain type of what you can say features, feathers, colors, likewise family, and then you are these are called as attributes. For example, if you say a person as a class, their date of birth, nationality, social security number, address, these are called as the attributes with which we can define that entity. But there are certain operations that entity can do. For example, person can eat, person can sleep, person can exercise, person can swim, person can dream, person can dance, person can do many things. But not all persons can do those things. For example, if you consider ASR as an object of type person, okay, the ASR as an object of type person may or may not swim. Okay, so not all operations are available with the object, but all attributes even may not be available with the objects. So some attributes and some operations are available with the object, and so class and object difference is that class is what you can say the generalized definition of set of objects, while when we say object, it is an individual part. For example, here if we say the student as a class, we are having Abhishek Patil as a student, Aishwarya Manmode as a student, Shinde as a student. Okay, likewise, right now we are having here total 69 students here in the group. And if you go with the 69 student in a group, you will find that all these students are what you can say the object. All the students are objects of type class student. Okay, so you can say Abhishek Patil is an object of type student, Aishwarya Manmode is an object of type student, but there may be some attributes of Abhishek Patil which are not available with Aishwarya Manmode. There may be some attributes of Aishwarya Manmode which are not similar or available with the Abhishek Patil. Yes, Abhishek Patil can play, say, suppose a good flute. It may not be the reality with the Aishwarya Manmode. She may not play the good flute. Okay, so this is what we can say, the not having the all operations and not having the all attributes. Age, height, weight, date of birth, they may be different. Okay, so the values of attributes may changes. Some attributes may not be there. Some attributes may be there. And that is what we call say object. So when we say element of a class-based modeling, we are considering classes. Student is here a class. Objects. All the students are considered as a set of objects which are defined by the single class student. Okay. Then you are on the attributes. Attributes means all those values with which we can identify you. For example, your roll number is one attribute, and this attribute is different for every object. Okay, this attribute is different for every object. Then you have some operations. After this, there is a class responsibility collaborator or CRC model, or what we call as a class relationship model. Every class is related with the other class. For example, if here right now, if you consider the two classes, as one class is a mentor class, in which right now I am an object of the mentor class, and here you are having the multiple objects. That is what you can say of the student class. Okay, multiple objects are generally shown with the such a type of symbol in UML. So you are in the multiple objects which are related with a simple class. So you are having the one mentor can teach many, you can say, student. So this is what this single thing, that is one mentor can teach many students, is called as a collaborative relationship. And when we have such modeling of the two classes, okay, we call this as a CRC, class responsibility collaborator. So this class is having its own responsibility, mentor class, and this student class is having its own responsibility. So this class, when we say these objects, we call this as the object diagram. Okay, and if you are showing this simply as one class as a mentor, another class as a student, there is a relationship in this mentor and student class. That is the mentor ASR is right now giving a lecture or delivering a lecture to the student class. Then this is what we can call as class-based modeling. Okay, now what we have to consider here is that is this class element of class modeling. What is the importance of having such a model in requirement analysis or in requirement or software requirement specification? Because these classes give you the exact idea of how to divide your database, how to distribute your database, what responsibility should have to be gathered, or how to put into a particular type of structure, and likewise. And so it helps you in designing and defining your software in a correct way. So once these things are done, that is, all the classes of your softwares are identified, all the objects of this identified attributes and operations are defined, and you got the CRC relation or the CRC model of this, or what generally called as a class diagram. You can go with the collaboration diagram and the package diagram of the class-based modeling. So what we require, how to identify the analysis classes, or how to examine these classes. Obviously, if you want to examine all these classes, we require to go through the one thing, and that is our use case model. Okay, so when we have this use case or scenario based model as a part, we come up with the thing. So when we grammatically parse on the use cases develop, for example, you can say end user can log in, or end user can register. So we already know that there must have to be some database which require to have certain attributes and certain things which can help the end user to register himself or herself. And that is what we can call as the grammatical parse. Then we can have the classes which are determined by underlining each noun, or what you can say the noun or noun phrase, and entering it into a simple table. So suppose if I am having a simple use case where I say that user need to enter his username and password, and that should have to be get authenticated. So you know that there is a this is a simple use case, but here I am having the username and is password and need to be authenticated, means I also have one process to authenticate. So I find out that there is a requirement of a database where I require to store the username and the password, and there should have to be some mechanism to check this password against the new password entered by the user for validity. And this is what we call as a classes determination. Then if the class is required to implement a solution, then it is a part of solution space. There are some certain classes which won't require to implement a solution. We call this as an abstract class. Okay, or you can say those classes may not sometimes won't require, but if the class requires some methods, for example, I am having a class which says report class. Okay, so report class can create the different type of reports. So each have the one attribute type of report. It may be a type of report, maybe bill type of report, maybe end of the day report type of attendance report, and likewise, and we can go with that simple thing. And if a class is necessary only to describe the solution, it is a part of problem space. There are certain classes what we call as a profile class of a software, which is actually simply used to define the entire software. And so it is a class which is necessary only to describe a solution. It is a part of problem space. So now the next is what are the analysis classes manifest. Okay, how they can manifest themselves, and likewise. So first, they can be external entities. So what are the external entities? Other system, other devices, and people. For example, let's say suppose you created a software system, a simple web application which required to transfer the data from one system to another system. So this like the you can say file sharing application. Now when you are transferring this data, FTP, file transfer, okay, you actually require to deal with the other system. So that other system is your external entity, which may be the class. So this is the analysis class. This is not the part of your solution, but is a part of your problem space, and that you have to consider. Then devices may be there. You require to communicate with the Bluetooth device, or you may require to communicate through Zigbee, or you may require to communicate through Wi-Fi and something. So yeah, or you may require to communicate with the printer. All these are you may require to communicate with some router. So all these devices are there, and this communication happens between your application, or that between your software and that device. And software also required to communicate with the people. So if you see these people that produces or consume this information, and that is what we call as a computer base. So first analysis class is what? Our external entity. Okay, so anything which is external to your software, it may be other system, other software, it may be the hardware or devices, or it may be the people. That is called as external entities. That is a part of analysis class. Okay, then you are having some things. Now what are these things here? The example of things are already given here. The reports, displays, letters, signals. For example, you created a simple web application or a website, and this site required to be you can say hosted on a mobile phone, on a browser, and say on laptop and on desktop. So accordingly it have to manage itself. So when it go on managing, it have to identify the different type of displays. Yeah, letters, signals, and these are so that are part of the information domain for the problem. So generally when we say things, these are the classes which are called as an interface class, or these classes many times these are not the user interface. Okay, these classes are what you can say output delivery interfaces. Okay, so then you are having the class which is called as occurrences or events. For example, you may have a simple class which actually directs certain type of occurrences or event. For example, if you go with the mouse as a class, then mouse over event, mouse click event, mouse you can say right click button event, and likewise all those things are what you can say occurrences or event. So these classes actually allows you to define the different type of you can say small operations or sensitiveness in your application. So this is what you can say the analysis classes. The analysis classes again, if you go with, you can have the different type of analysis classes, and this is the next is the roles. Right now we are playing the role. You are playing the role of student. I am playing the role of mentor. So maybe the vice versa. If you know something better and you want to, I can say, present that, then you are giving information to me, automatically role changes. Okay, so now you become a teacher for a while, and I become what you can say a student for a while, because to student to study or being a student means that you require to hear the person, and you have to extract the knowledge from whatever that person is saying. Okay, so those are the roles. So you may have the role of manager, you may be the engineer, you may be the salesperson in a team. For example, if you go with the team as a software team, you can have a simple software team as a team leader. You may have the participants, and likewise. Right now, today we are having only 68 participants. We are having around 136 students registered, and only 68 participants. This is very poor attendance for today's session, which happen sometimes. Okay. Ask your friends to log in. So time is still there is a time, and their attendance will be marked accordingly. Then, okay. So right now we are on. So then we are on the organizational units, divisions, group, teams, and likewise, and something. So these are the analysis classes. Organizational units are also there. Then we are on the places, which can be manufacturing floor or loading dock, something. These are also the classes. For example, let's say suppose if you are creating a IoT based software. Okay, IoT based software, and this IoT based software controls and a lift operation. Then you require to show the places, the first floor, second floor, third floor, fourth floor, fifth floor, where to stop, how to stop, and likewise all that training required to be given to this, and these places actually shows the different type of operations that can be handled at that particular place. So if you consider this analysis classes, places is the one class. Then you are in the structures. So sensors, four-wheel vehicles or computers, they define the class or objects of related class or objects, and they actually define the structures. Okay. So a particular type of sensors and a particular type of, you can say, data, say two or three different type of attributes and data can create one entity, and if you are having such entities to work with, then you can say that as a structure. For example, when you say a form is a structure, that is the one type of class. Okay, and this what you can say, these are the analysis classes that you require to identify when it comes to class based responsibility. Now these two scientists, Code and Eldon, they suggested the 6 selection characteristics for the proper SRS. Okay, proper SRS, and these 6 characteristics are that as you consider each potential class for inclusion in the analysis model, these are used. So right now we are having total 68. One are left and candidate here. Okay, I'm just playing this to show you the name. This recording will be uploaded to YouTube by today night. Okay. So here you are having this code and Erdogan. This suggests this 6 selection. Then what we are having code and Erdogan 6 selection characters for, you have to retain the information. Okay. So the potential class, that is must have to be retain the information. When you can retain the information, when you can make that class persistent, or in our regular language, persistent class is called as a database. So when we say a class, we are actually considering, or we are saying that the class must have to retain the information. Okay. The next thing for selection of the things, a class is definable if there is a need of service. For example, let's say suppose you are having e-Shopee software development, then transferring the data or to making some transaction is your necessity, and in that cases you require the services. So potential class must have a set of identifiable operation or services in it. Without operations, if you are in the class, for example, if you go with an abstract class, it generally have only name, no attributes, and no operations. Many times very few attributes, but no operation at all. Or simply the operation names are defined, but actual operations are not defined. So that is what called as abstract class. And abstract classes are not considered here. We are considering the proper classes, which are full with attributes and likewise. Then there must have to be multiple attributes to the class. Why you require multiple attributes to the class? Simple thing. Attribute. For example, let's say suppose if you want to identify someone, then the person must require to have name, must have to have the age of date of birth, must have to have nationality, must have to have height, weight, and all those things. So all those are the multiple attributes which define the entire person. Only name won't define the entire person. Yes. So if you consider something, so there are the multiple attributes which require to be present in the class definition. Then there must have to be common attributes to make all objects into a one class. For example, all of us are having a name is a common attribute, date of birth is a common attribute, height is a common attribute, social security number is a common attribute. Their value may be different, okay, but attribute is common. So variable name is there, attribute is common, and so we require to have classes must have common attributes. This is the one thing. It must have the common operations also. For example, we all can do the similar things. For example, I can open work on the laptop, you can work on the laptop, I can read, write, you can read, write. So we are having this set of common operations that we are having. Then there must have to be some essential requirements in every class that we want to add into the software. For example, let's say suppose if you are in a form class, what are the essential requirements of a form class? A form must have to submit all the data in a secure way. So there must have to be a submit button. Likewise, those operations are there and those requirements are there. Then it must have to communicate with the external entities and like. And so when you say essential requirements, we have to deal with this. So these are the six what can say attributes or selection characteristics which are given by code and order. The specifying these attributes, how to specify the different attributes of a class. So attribute actually describe a class that has been selected. So attribute is nothing but the different variables. So you have to find out whether class is important or not. So if you say to develop this set of meaningful attributes, we require to study the every use case of the requirement analysis. Once this is done, we require to answer this what data items composite or elementary fully define the particular class, and accordingly you have to gather objects together into that class. So to define the different operations in a class, you require to identify the operations with the object. For example, let's say suppose if you have the printer as a class, then you may have the Epson printer, one object, laser printer, another object, dot matrix, one object, virtual PDF printer is an object. So operation defines the behavior of an object, how that object will. It not define the behavior of a class, because class is a static generalized entity. But at the time of that particular instant, whichever object is active is called as the object, and you have that class, the operations in a class actually define the behavior of that particular object. So this is thing, operations, they may be divided into four categories. First, the data manipulation objects, operations. Second, operations that is a computational. Now, what is data manipulation of operations? That is adding data, deleting data, modifying data, reformatting data, appending data. These are the data manipulation. Okay, or analyzing the data. Operation performs computation, that is plus, minus, and all those things. Then operation that inquire about the state of an object. So these operations are trying to identify what is the state of object. Then maybe the operations which are used to control and monitor the entire control. So monitor an object and the occurrences of it. So you have to have these operations. Then the study processing narrative, that is in use cases to select these operations. because you can get these operations only from the use cases. For example, if I give the use case, our user need to log in into the system using his username and password and get other authenticated by the system. This is a simple use case. There, if you study this, you know that user requires username and password. There require to be a authentication mechanism, and if both things are far from each other, means client server mechanism, there must have to be some secure transaction of this username and password over the network, and this gives you the entire, what you can say, the operations implementation idea. So we get additional insight into other operation by considering the communication. And likewise, so if you go with the CRC model, for example, here you are having, if you go with a floor plan of building, you are having the floor plan. The description of floor plan is responsibility, what it defines the floor plan name. Okay, it may be a slab, it may be what you can say, a floor. For example, if you are on a second floor, okay, your slab, your floor is actually the slab of the first floor person. So floor plan is there, manages floor plan positioning, and likewise. So these are the different responsibilities, and which classes are deal with this. You every floor will have the wall is a class, and if you have the CCTV camera, then that. So you are having the one class, and these are the classes related or the collaborating with the class. So this CRC modeling is required to identify the different what you can say, identifying different relations between different classes, and you have to be very careful while doing this CRC model, because this responsibility collaborator or relationship collaborator model actually gives you what you can say, the idea about how your system is going to collaborate with each other. For example, when you open some menu, file, edit, print, you are in the different menu. Those are the different classes or packages, and they collaborate with each other to give you the actual experience. So here is the collaborator experience. Floor plan is there. One floor plan, it may have the one camera, it may have the four walls. Okay, so it need to be built, and likewise, so all these, there is a wall, segment, window, door. These are the subclasses for this. So this entire system called as a responsibility collaborator model, collaborator modeling. Then entity classes, these are also called as the model or business classes. They are exactly direct from the statement of problem. Example, floor plan, sensor, and likewise. There are boundary classes. This create the interface, or what we call as a user interface, interactive screen, printed reports, and other things. These classes are called as a boundary classes. Okay, then you are having these different classes to go through. Then you are in the controller classes. Controller classes are those classes which actually help to monitor the entire process. So main program, if you have the different sub programs, then the calling main program is called as a controller class. Okay, so it's a creation and update of the entity objects, instantiate the boundary objects, means user interfaces or client programs, complex communication between sets of objects, and creating logs and everything is done by these controller classes. Okay, these are not considered until actual design activities. So controller classes are generally abstract, at a very abstract level, when it comes to requirement specification or requirement analysis modeling. Okay. Then the scientist is Wirf, Brock et al. And Brock et al. They give the 5 guidelines for allocating responsibilities to classes. First, the system intelligence should be distributed across the classes. Means monolithic class design is not. You have to have the different classes, and they must have to deal with each other. Then each responsibility should be stated as generally as possible. There must have to be some description given to the every responsibility. Information and behavior related to it should have to be decided within the same class. Means if you have the class like a student, study is the operation of the student, must have to be within the class of the student. Okay, then information about one thing should be localized with a single class. Means if you are having certain information, for example print report, there must have to be a printer class, and the print report operation required to be only in a printer class and not in other classes. Instead, other classes have to call that printer. So function class can be you can say synonymized here with the functions. and responsibility should be shared among all the related classes appropriate and like. So here you are having a player as the main class. Player is having a head, player is having a body, player is having arms, and player is having the legs. This is called as aggregation. Okay, so player is actually the aggregation of all these different classes. So collaboration actually fulfill the following. It can use its own operation. It can use the friends or other classes operations by collaborating with them. Okay. So when you say class responsibility collaborator, class require to use its own operation, and for some operation it may collaborate with the other classes to complete those operations. So collaboration is a part of relationship, and it may be the aggregation, it may be inheritance, it is the has knowledge of relationship means the class may be related with something, a class must acquire information from another class, so it has a knowledge. It may be the dependency relationship on different class thing. So these are the different relationships. For example, wall and wall segment. Wall segment is one to many wall segment can be used to build a wall. So this wall actually uses different wall segment. One to many window can be fitted into one wall. Okay, a door, one to many door is used to build a wall. So this is what we call as an association collaboration. This is a dependency. Display window depends on a camera. Camera is not depend on the display window. Okay, and for the access and password. So these are called as a dependency collaboration. Okay, so there are such dependencies, that association dependency and this relationship, they are generally shown with different type of symbols. If you go through the UML books, you will find those symbols very well. Here you are having the packages. Now what is packages? For example, if I say this as a file package instead of environment, you know, new, open, save as, all those properties or classes are gathered together to make a single package. Okay, then you are in the edit package, you are having the print package, you are in the help package. In the same way, you are having these different packages. So important part of this analysis modeling of the requirement is that is you try to package all these classes together. So first you identify the similar type of objects and you create classes for them. Then you find the related classes, and based on the CRC or class responsibility collaboration, you create the package. For example, this tree, landscape, road, wall, bridge, building, visual effects, scene, they are related with each other by somehow, and so they are gathered together into a single package environment. Okay, so this is the end of today's lecture. If you have any questions, queries, you can ask those questions and queries right now. Okay, in a chat and something. If you like today's session, just give me the thumbs up in this chat. In chat window, give me this thumbs up, because question and answer is not visible to me. Right now I am acting like a participant instead of say. Okay, just give me the thumbs up here. Or just say yes, like. Okay. You can say here as an yes if you like today's session. We will going to see actual design and development of classes. Okay, and after the end of the second unit, means after the 2 sessions, tomorrow on is Wednesday, and then Thursday. On Friday we will have the TAE 1. Okay. Hello. Hello. So shall I stop the sharing? Yes. So if you have any question, queries, you can put, or shall I end the session now? Today's attendance is very poor.